Below the surface of a tropical reef, the water is crowded with constant motion. But if you watch the edges where the light begins to fade, you might spot a solitary silhouette hovering completely still, watching the chaos. This right here is the Atlantic barracuda. A fully grown adult commands immediate respect in the water. They routinely reach lengths of 1.5 to 2 meters, packing up to 30 kilograms of dense muscle into a sleek, streamlined frame. On this habitat profile, we see exactly where they operate. They hunt across warm, shallow waters, coastal margins, seagrass beds, and tropical reefs, dominating the water column from the surface down to a depth of 100 meters. What makes this animal a top-tier predator is its capacity for acceleration. Without warning, a resting barracuda can launch from a dead standstill to speeds exceeding 50 kilometers per hour in a fraction of a second. Moving that fast underwater requires specific biological adaptations. To understand how they achieve this success, we have to look past the top-line numbers and break down the specific engineering of their anatomy. Every successful ambush starts with target acquisition. Before the barracuda even twitches a muscle, its sensory array is actively mapping the environment. The environment of a deep reef is visually complex and heavily shadowed. To compensate, the barracuda is equipped with oversized eyes, optimized for gathering available light, giving it sharp optics that can spot movement in murky or low-light conditions. This visual system is calibrated to track the erratic movements of its primary food sources: small schooling fish, a passing squid, and tiny shrimp. But seeing the prey is only half the equation. The predator also needs to remain unseen. The barracuda utilizes active underwater camouflage. Its scales are a highly reflective silver that mirrors the surrounding water, while dark vertical stripes along its flank break up its silhouette against the reef background. By combining enhanced low-light optics with this disruptive coloration, the predator is able to hide in plain sight. It sits perfectly still in the water column, remaining undetected by the prey swimming right past its nose. Once a target is locked in those sights, the waiting ends. The barracuda transitions instantly from absolute stillness into the sprint phase of the hunt. Its body is shaped like a torpedo, designed to slice through the water with minimal drag. When the dense musculature flanking its spine ignites, it translates massive kinetic energy straight into the tail fin, producing that 50 km/h burst of propulsion. This anatomical diagram highlights the final piece of the sequence, the primary weaponry. The jaws are loaded with long, needle-like teeth, arranged in an irregular, offset pattern. The specific shape of this jawline gave the animal its name. Barracuda originates from the Spanish language, translating quite literally to fish with sharp teeth. The bite is a mechanical trap. The teeth are angled slightly inward. When those jaws close around a target, the offset arrangement creates a physical cage. The more the prey struggles, the deeper it drives itself into the teeth, making escape physically impossible once contact is made. The combination of high-velocity propulsion and a grip that prevents escape makes the barracuda a highly effective biological missile. That offensive capability is heavily concentrated in the solitary adult. Before they grow into apex hunters, juvenile barracudas are vulnerable to the open ocean, forcing them to adopt a very different survival strategy. Young barracudas gather by the hundreds. They group together in a massive, tightly packed formation, swimming in a continuous, synchronized circular vortex. This swirling tornado of silver bodies acts as a collective defense mechanism. When a larger predator tries to target an individual fish, the endless, strobing movement of the school overloads its visual tracking system, making it difficult to lock onto a single meal. As they mature and leave the school, they develop a reputation for aggression. But the reality is that barracudas are opportunistic hunters, not active man-eaters. They have no natural interest in humans. As this instructional graphic shows, accidental bites usually stem from biological confusion. Because they are visual hunters, they can be triggered by flashing, high-contrast jewelry that mimics fish scales, the scent of blood in the water, or discarded fishing bait. Coexisting with them in the water is straightforward. Divers and swimmers simply need to respect their space, avoid wearing shiny objects, and never attempt to feed or provoke them. Currently, global populations are stable, earning the species a least concern conservation status. However, maintaining those numbers relies on responsible marine practices and the preservation of the reef environments they call home. The Atlantic barracuda is a highly specialized hunter, a vital regulator that maintains the balance of the reef ecosystem. By understanding its biology, we can look past its intimidating profile and recognize its role in the health of our oceans.